Please make sure that you have handy your copy of the assignment Chemical Properties of Elements. This lab that we're going to do today looks at how different elements react or don't react with the same substances. And it also deals with how the periodic table got to be arranged the way it is. In the early days before the discovery of the electron and the nucleus, chemists were trying to find a way to organize what was known about the elements, and the periodic table is the result of their work in that area. So we're going to be working with a type of compound called an ionic compound. There's some examples right here. When you look at the formula or the name of an ionic compound, it has two parts. The first part is the positively charged ion in the compound, and the second is the negatively charged ion in the compound. So like sodium chloride, the sodium element, sodium is a metal, chloride comes from chlorine, which is a nonmetal. Those positively charged metal ions and negatively charged nonmetal ions join together to form the compound sodium chloride. It's an example of how they come together. Think about like magnets. North and south ends of magnets stick together, opposite polarities of magnets. Something similar happens in ionic compounds. The positively charged metal, whoa, get that focus, and the negatively charged nonmetal, they stick together like socks in the dryer, opposite charges attract. Now, in our experiment, we're going to be working with mixtures of ionic compounds, and when you take two different ionic compounds and put them in water, some of the ions will come apart and the substance will dissolve, and then they can rearrange who their partners are and form new combinations. Some of those combinations will stick together, and when they stick together, then they're no longer soluble, they no longer dissolve in the solution, and you can see them precipitate or snow like a white powder. And we'll look to see which combinations form new compounds. So starting with one combination, if all the ions are present in the solution, if they rearrange to form new compounds, we'll try to figure out what new compound was formed so that we can determine which element was involved in that reaction. Okay, let's take a look at the procedures for the experiment. When you go back to the lab bench wearing your lab goggles, you'll find a set of 6 test tubes. In these test tubes are 6 ionic compounds containing metal ions: lithium, sodium, potassium, magnesium, calcium, and strontium. And we're going to make solutions of these by mixing them in water. You'll also find 3 solutions already made for you that contain the negatively charged ions. There's phosphate, which is made of phosphorus and oxygen, both nonmetals, and carbonate, which is made from carbon and oxygen, both nonmetals, and chloride, which is a chlorine ion, which is a nonmetal as well. So these negatively charged ions, all made from nonmetals. And what we're going to do is we're going to combine all of those different combinations in cups on a grid, and the grid is laid out the same way as the data table on the back of the first page. So when you're setting up the experiment and taking your data, the way that these cups are arranged is the same as the way the data table is arranged, so you can tell which combinations are being tested in which cup. Just a quick word about making solutions and observing solubility. On the back of the first page, I want to just go through the solubilities of the solutions that you're using that contain the negative ions, including one that you're not going to be testing, but one that's still an important part of the investigation. This one right here, ammonium nitrate. Let me show you how to make a mixture using this one and how to make observations of solubility. So I've got a cup about half full of water, and I'm going to add a good spoonful or 2 of that substance. 1, 2, and then I'll mix it around. And what I'm looking for is to see if it's soluble. If it's soluble, that means that the ions that make up the compound are going to separate and come apart, and the solution is going to remain clear. If it's not soluble, then the solution turns cloudy. And what we're looking for is whether or not the solutions that you make when you mix together the different sources of ions are clear or cloudy. So as I'm finishing up mixing this one, I'll see that it's remaining, it's a little bit cloudy at first, but the more that I mix it, the more it's going to turn clear. Look, you can see the spoon right through it. So this is a soluble substance. The ammonium nitrate is soluble in water. You can see right through there. The other substances, you'll pour these half full cups, and you'll see that they are also likewise soluble. The chloride is a clear, colorless solution. The carbonate, when you pour this one out, you'll see is a clear, colorless solution. And the phosphate, when you pour that one halfway into a cup, you'll see that this one is also a clear, colorless solution. So we're starting with substances that are all soluble in water. When you go to make the substances, the mixtures for your experiment, fill up these cups half filled with water. They are matching the elements that you're testing. There's one label for lithium and one for sodium and potassium and so on. Use the test tubes and use a clean spoon, 1 or 2 good scoops. If you use the spoon again, make sure to clean it off. Just wipe it clean with a paper towel before you use it again and make those mixtures. Then what you'll do is you'll take the mixtures and pour the chloride solution into all of the cups that are in the same row with chloride. Pour some of the carbonate into all of the cups that are in the same row with carbonate. Pour some of the phosphate into all the same cups in that row. And then the lithium will pour into the 3 cups that are labeled for lithium, and then 3 for sodium, 3 for potassium, and so on, until we've made all the possible mixtures. And what you want to do is look in the cups and see if the mixture that you make is clear, in which case everything is soluble, or not clear. If it's cloudy, if it looks like white milk, then that's going to be insoluble. And we'll keep track of the solubility of the materials that you're working with on the data table. So the one that I showed you, ammonium nitrate, I would circle that it's soluble because it made a clear, colorless solution. And the other ones, ammonium chloride, ammonium carbonate, and ammonium phosphate, those are all soluble as well. When you look at their cups, they're clear, colorless solutions. The metal-nitrate solutions that you're making, they're all soluble as well, so make sure that they're mixed until they're clear and cloudy, colorless, and then mix them in the cups. When you're all done, you can pour out these cups and you can throw them away. You can pour out these cups, but don't throw those away, and don't throw those away either. All right, let's get to work.